All right, so section 6.1, similar polygons. I'm going to slide right to the next little thing, which is key vocabulary. So the slide right under there says key vocabulary. Let's fill in our definitions for similar polygons and similarity ratio. Okay, so the first one, similar polygons are polygons with congruent angles but not congruent sides. Okay, the sides are not going to be congruent, the sides are going to be proportional. So congruent angles and proportional corresponding sides. And when I say congruent angles, it doesn't mean that all of the angles have to all be 90, right? So it doesn't have to be a rectangle or a square or something like that. These two polygons right here are similar. So basically, visually, what it's going to look like is they're going to be the same shape. They're going to look the same. They're just going to be a different size. Okay, so like one is going to be half the size of the other, for example. Okay, so right here it's got a similarity statement. So I want to point this out. This is a similarity statement. If you'd like to write it bigger so you can see it a little bit better, you can. It says A, B, C, D is similar to E, F, G, H. This is a similarity statement, which should be somewhat familiar because we did congruency statements. Okay, this is the same idea, it's just similarity instead of congruency. All right. The other thing that's similar to when we were doing congruency is angle A is going to be the exact same measure as angle E. So it was the same for congruency. Angle B is going to be the exact same as angle F. C is going to be the same as G, and D is going to be the same as H. It is not true, however, that AB, the side, will not be the same as EF, the side. Okay? So the other thing is that there's going to be a scale factor. So the scale factor is going to be the ratio of the lengths of the corresponding sides. Okay. Hopefully the word ratio is not new because we talked about a 2-to-1 ratio when we were talking about the centroid with the median, breaking the median into a 2-to-1 ratio. And the same kind of thing is going to happen. So let's just pretend that this is a 2-to-1 ratio. It's not because that doesn't look twice as big, but let's say this was 2, then its corresponding side would be 4. So the ratio would be 2-to-1. And when you do the ratio, it is best to reduce the ratio. You can write the ratio as 2-to-1 or 2-to-1 as a fraction. Okay. The part that's going to be necessary for you to pay attention to is when I write a 2-to-1 ratio, my similarity statement, A, B, C, D, is similar to E, F, G, H. Okay, when you write that similarity statement out, this number should go with this shape. Does that make sense? Whatever shape you write first, its number should go first in the similarity ratio. Okay. So part of your homework is going to be writing out a similarity statement and a similarity ratio. Okay. Make sure that your statement and your ratio match up. Okay. Let's do a little practice. Okay, so it says right here that our ST is similar to XYZ, which means angle R and angle X are going to be the exact same. So I'm going to just mark that in the picture. So R is this guy here. So R and X are the same. Which just kind of gives you a visual to see which sides are going to be proportionate to each other. Okay, so it says list all the pairs of congruent angles. So angle R is going to be congruent to. So angle R goes with angle X. This I don't even need to look at the picture for. I can just look at the statement. Angle S goes with angle Y, and angle T goes with angle Z. Okay, so what I did there is I just listed them out from the similarity statement. R goes with X, S goes with Y, and T with Z. Okay, that's pretty straightforward. This one says check the ratios of the corresponding side. So because I marked that, it's a little bit easier to see that this number here, which is 30, goes with this number here, which is 18. Okay, so if you're checking the ratios, the first one is 30 over 18. So we're just checking to see are all of the ratios of the three sides the same. So I'm going to kind of set them up. So one of the things that gets kids all the time is, well, what number do I put next? What number do I put next? What number do I put next? The easiest way to do it is just to go big, medium, small. Big, medium, small, right? And those numbers should line up with each other as far as the ratio is concerned. So my biggest number was 30. Then which one should I do next? Well, I've got a 25 and I've got a 20, right? So put them in order. 25 and 20. Because the biggest side of one triangle should line up with the biggest side of the other triangle, if they are actually proportionate. And then over here I went 18, and then it looks like I got a 15 and a 12. So 15 and 12. Okay, so do those add up? How do I know? You've got three different ways to check. Number one, you can reduce all the fractions and make sure they reduce down to the same fraction. Second thing you can do is you can type them into a calculator and see if they give you the same decimal. And the third thing you could do, probably don't want to, but the third thing you could do is you could cross multiply these numbers and see if you get the same number. Okay. So if you reduce them down, let's try that one first. So if I just reduce these by, what do 30 and 18 have in common? 3. They do have a 3 in common. So if I reduce 30 and 18 down by 3, that's a 10 and a 6. Can I reduce it even more? Yep, just one more time we'll reduce it by 2. You just throw something out there, and if you need to keep going, you keep going. So 5 and 3. It was a 6, and then I just reduced them by 2 again. So I just reduced twice. Okay. So 5 over 3. Does 25 over 15, would that reduce to 5 over 3? Yep. What about 20 over 12? Would that reduce to 5 over 3? Yeah, if I divide by 4. Okay, so those are all in the same ratio. So then it says, write the ratio of the corresponding side lengths in a statement of proportionality. What does that mean? That means we're going to kind of set up the same thing that we just did. So 3 equal fractions, but we're just going to write out the side lengths instead of the numbers. Okay, so my side length for the 30 was TS. So I would go TS, that was the big one. Then maybe go TR, that was the medium one. And then RS is the small one. So I just went big, medium, small. Could I go small, medium, large? Sure. And then TS would correspond with, we did YZ there, or ZY, whichever way you want to write those letters. And then the next one would be ZX, and then XY. So that's my statement of proportionality, because I'm just showing that these 3 ratios are all the same, which makes a proportion. Okay. Okay. Moving on. So far, so good? Yeah, it's kind of like congruence, but just a little bit different. Okay. Okay, so I'm going to write out what this is saying. This is straight from the book. It's like for your notebook, but I'm going to write out on the side what this is actually saying. Yeah. Yeah. So the first one is it's it's very hard to read it.
I didn't finish the other notes.
Oh, I'll get it to you. So it's really hard to read what it's saying kind of on yours. So basically what it's saying is that the ratio of the sides, okay, so let's write, looks like Kn and Ps go together. So whatever ratio that is, Kn to Ps, whatever that ratio is, so let's say it's a 1 to 2 ratio, right, because Kn is the smaller one. So let's say it's a 1 to 2 ratio. What this is saying is that if I added up all of the sides of the smaller one, and I added up all of the sides of the bigger one, the ratio of the perimeters would be the same as the ratio of the sides. Okay, so the perimeter of K, L, N, M, I just put all the letters, over the perimeter of P, Q, R, S, that's supposed to be a P, sorry, P, Q, R, S is equal to the ratio of the side lengths. Which for a quadrilateral, so for like a rectangle, for example, it would not be super difficult for you to just find the length, which we're going to see in a second. But if you had a pentagon or a hexagon or an octagon or something that had more than 4 sides, this is really nice. It's easy to help you figure out the perimeter when you maybe only know one of the sides instead of all of the sides. Okay? So that's what this is saying. It's really kind of hard to read that, but it's saying that the ratio of the sides is equal to the ratio of the perimeters. Okay, and we're going to use that in a minute. So I'm going to flip this over. Flip over to the back side. And now we're actually going to do some math with this. Okay, so let's actually do some numbers. So we just got all of our theorems kind of in check there, and now we're actually going to do some numbers to find x. Okay, so what you need to do, what you need to know algebraically before we do this geometry stuff is you need to be able to solve something like that. Okay, which is just a cross multiply, right? So what I'd like to make sure you do is, yes, it's a cross multiply, but hopefully in our calculator what we're actually going to do is we're going to multiply these two and then just automatically divide by this one. Okay, so like in one line of our calculator, we're going to multiply, divide, and be done. Why? Because every time you solve a cross multiplying problem, what you do is you multiply 12 times x, and then you multiply 5 times 9. After you cross multiply, what do you do with the 12? You divide every single time. So when you cross multiply, let's take it from algebra 1 and let's kick it up a notch a little bit. If you're cross multiplying, what we're going to do is we are going to multiply the two numbers, and then we're going to go ahead and just divide by the third number. Okay, so we'll work on that as we are moving forward and doing these problems here. Okay, so it says determine whether polygons are similar. If they are, write a similarity statement and find the scale factor, which is the similarity ratio of the two. How do I know for sure? First of all, you check the angles. Are all of the angles equal to each other? So this angle equals that one, we're good. That one to that one, we're good. That one to that one, good there, and good there. So we checked all the angles. The angles have to be similar. And now we check our side lengths. So I'm just going to go ahead and write out our proportions here and make sure that the ratios are all the same all the way across. Janetta? There we go. Thank you. So when I write these out, again, you can go smallest to largest or largest to smallest. It doesn't matter. So I'm going to start with this figure here and find either the biggest or the smallest one. So it looks like the smallest one is 12. So I'm going to go 12 and then 16 and then 20 and 24. And you're just going to see, do those numbers line up with, is the ratio the same all the way through as the other one? So find the smallest one. So 15. Then it looks like 20, 25, and 30. So again, you kind of just check the ratio. So 3 ways to do it. You reduce all the fractions. You divide all of them to see if you get the same decimal, or you can do some cross multiplying. Okay, if I just reduce these fractions, reduce this one by 3, you get a 4. Reduce this one by 3, you get a 5. So 4 over 5 looks like it is the simplified ratio.
How do you know whether to do it the smallest, the biggest, or biggest to smallest?
You get to pick that. Just put them in order, because what happens sometimes is that this one is super nice because the figures are oriented the same, they're facing the same direction, but if they happen to be flipped, you might try to line up the wrong numbers, if that makes sense. Okay, so that's why I do it, just start either at the smallest or the biggest and just go all the way across. Okay, so do you actually have to do it smallest to biggest? No, you could put them in any order you want. It's just a good idea to do it that way to make sure that you're lining up the right numbers. Okay, it's a good question. If I reduce these, do I get a 4 over 5 ratio? Yep. Is this one 4 or 5? Yep. This one's 4 over 5? Yep. So we're good there. So then it says to write a similarity statement and to find the scale factor or the similarity ratio. So I'm just going to copy it. It kind of set it up for you here, right here. ZYXW. So ZYXW similar to FGHJ. And now we need to do the scale factor or the ratio. Okay. Is this one, ZYXW, is that the smaller one or the bigger one? ZYXW, that's going to be the bigger one. So what you have to make sure is, I did a 4 over 5 right here, but when I write it out this way, the number that I write first in my scale factor or in my ratio has got to be the number that goes with this shape. So because this shape is the bigger one, my ratio is 5 to 4. So you have to be careful when you write down the similarity statement and you write down your scale factor or your ratio. It's got to match up with what you wrote down for the similarity statement. Okay, just be careful about that. It gets messed up a lot. Okay, let's find the value of x here. It says already that these triangles are similar, so that means I can set up a proportion. Okay, how do I know which ones go with which ones? Well, you can use the similarity statement if you can't visually see which ones go with which ones. So for sure, I'm going to put x with 20. And then you pick. Do you want to go 9 with 12? Or do you want to go 12 with 16? So 9 from the small triangle and 12 from the big triangle, or do you want to use 12 from the small triangle and 16 from the big triangle? Okay. So what I did is I set it up so far. This is a number from the small triangle. This is a number from the larger triangle. So you just have to make sure whatever number you pick. So I'm going to pick this 9. That 9 is from the smaller of the two triangles, so it has to line up with the x from the smaller triangle. And then I picked 9, so I've got to put 12 here. And then I grab my calculator and I just cross multiply, divide. So what I'm going to do in my calculator is I'm going to automatically multiply the two numbers that are across from each other, so 9 times 20, and then just right in the same line, divide by 12. You can't see that very well, but here we go. 9 times 20, divide by 12, is 15. And there's my answer. Okay. Okay. Let's do that a little bit faster. Okay. Let's come over here. More practice. So it's the same kind of idea. Find the scale factor. It doesn't actually ask you to check and see if they're similar. It's telling you they're similar. What's the scale factor? Okay. It also says to find x, y, and z, and then we're also going to find the perimeter. So we're going to use that little information about the perimeter too. Okay. So first of all, I want us to notice here this 135, the angle 135. That's for O. So if angle O is 135, then so is angle Y. And in my picture here, angle Y is labeled as the Z. So when I go to find my X, my Y, and my Z, I already know Z. Okay, the angle measures are equal to each other. So if that one's 135, then I've got a 135 over here. I have no idea what these other three angles are. They don't have to be 135. None of them have to be 135. Okay, I know that they should all add up to 360, but there's no rule about them having to be the same as each other. Okay, it does show you over here that these two are the same, top to bottom, or 12 and 12. And then here it shows you that the sides are the same, which we're going to learn what that tells us later. But we haven't learned that yet. So the second thing is to find the scale factor. So based on my similarity statement, I know that this, right here, this 8 for xy is right here. XY is going to line up with NO. So XY is 8, NO is 10, so my scale factor, or my ratio, is 8 to 10, which I'm going to reduce 4 to 5. That ratio right there is going to help me find X and Y. So if we start with X first, X is the side MN. So if I go X and 12 have to go together. Do you want to put X over 12 or do you want to put 12 over X? Completely up to you. So I'm going to go X over 12. So when I chose to do it that way, I put the number that I got from the larger triangle on the top, or the larger quadrilateral, and the smaller quadrilateral's number is on the bottom. So you need to give me another number from the larger quadrilateral. 10. Right? I know a 10. And we know that 10 goes with 8. Okay, so I'm just going to cross multiply this. So 10 times 12 is 120. And then go ahead and divide it by 8. Okay, so when I cross multiply, I multiply 10 times 12, and then just go ahead and divide it by 8. So I get 15. Okay, I can use that same ratio when I'm trying to find Y. Actually, I don't even really need to set that up. Do you know what Y is? Anybody want to venture a guess? Go ahead. 8. If this side is 10 and this side is 10, it's telling you those two sides are the same. So that's going to be true also for over here. So Y is going to be 8. We could set up a proportion, but it would look like 10 over 8 equals 10 over Y. So it's going to be 8. Okay, so here's what I know. I said X was 15, so I'm going to put a 15 here. And then based on this shape, I also know 15. So if I find the perimeter, I'm going to find the perimeter of MNOP, which is 10 plus 15 in your head, plus 10 plus 15 is 50. So my perimeter of MNOP is 50. Okay, so here's how we can set up this proportion. So again, we're setting up a proportion, we're cross-multiplying. That's going to be the name of the game for this entire unit. It's going to be proportion, cross-multiply, solve. Okay, so the name of last unit was set them equal, solve, right? So this one is proportion, cross-multiply. Okay, so if I do the perimeters on this side, my perimeter of MNOP is 50, and I don't know my perimeter for the other one. Could we figure it out? Yes, we could. But I'm going to just set up the proportion so you can see it. It's super easy to find the perimeter of the other one for this problem because I already found X and Y. I just want to show you the setup if it happened to be a hexagon or something like that. So this would be the perimeter. This is the perimeter of the larger one. This is the perimeter of the smaller one. Well, we know that the large to small ratio right here is 5 to 4, or you can use this 10 over 8 again. But that ratio still is usable for the perimeters as well. So whatever ratio you have, or scale factor you have, you can use that for the perimeters as well. So I can take 50 times 4 and divide that by 10 or by 5. Yeah.
Why are you using a 5-to-4 ratio?
Right here.
Yeah, why are you using it?
Because the ratio of the sides is the same as the ratio of the perimeters. So whatever the ratio of the sides are, which is right here, we found that out at the very beginning, you can use that ratio to relate the perimeters as well. Do I have to do it that way? No. I could find out the perimeter right here, because if this is 8, we know that's 8, and I could just add them all together. 8 plus 12 plus 8 plus 12 is 40. I'm just showing you if we're doing a different shape that's not as easy, this is how we could set it up. Okay. So we would get perimeter here, perimeter of the smaller one would be 40. So we have 50 for the perimeter of the big one, 40 for the perimeter of the small one. Okay. Last little bit here, we'll run through, again, we're setting up, and then we're cross-multiplying to solve. So we're setting up proportions, and setting up more proportions. Okay. So we'll set up the proportions. Down here for these last two problems quick, and then we'll cross-multiply and solve. Okay, so in the picture here, it tells you that they're proportionate. As we progress through, it's not going to tell you they're proportional. You have to look and see if they're proportional, and then use a proportion to cross-multiply and solve for x. But for right now, they're going to tell you that for sure is proportional. This triangle is proportionate to that triangle. Okay, so here's what I know. I'm going to put an x. They want you to know PS, so I'm just going to put an x right there. Okay. My general rule of thumb is I always try to put the smaller one on the top. I know we haven't quite done that, but I just wanted to make sure to show you you can do it anyway. But I usually try to put the smaller one on the top. I don't know why. That's just what my brain tells me to do. So if I put the number from the smaller triangle on the top, the larger triangle on the bottom, I would do something like x over, and then this number that corresponds with x right there is a 20. It's kind of hard to see on yours, but that's a 20. So I would do something like x over 20. Why can't I do 6 over 8 or 12 over 16 on this first fraction? You can. You can. You get to pick. You sitting in that seat right there, you get to pick any number from either one of these triangles to put down first. The first number you put down does not matter. So I'm choosing to put down x first. And because I chose to put down x first, then the number that corresponds with x should go on the bottom. Okay, so x is here, then my 20 that corresponds with x should go there. Now, you need to pick another number from the small triangle to put on the top over here. You can use 6. You can use 12. Do you see where I got 12? Because that's the whole side. So you could use either one. So let's just use 6 because it's smaller. It's a nice, easy number. And then whatever corresponds with 6 has to go on the bottom. So there's a little bit of choice here. So my proportion may not be set up the same as your proportion, but we will get the same answer. So what goes with 6 is an 8. And then when I solve this, I'm going to multiply here and then go ahead and divide by 8. So 20 times 6 and then divide that by 8 is 15. A lot of 15s. So x equals 15. So when you're doing your homework, please, please, please do show the setup of the homework just so that I can make sure that we're setting up the numbers correctly. The answers should all kind of match up. Okay. We're just going to do the first one, the new pool to the Olympic pool, because the other one is pretty straightforward. So a town is building a swimming pool. The dimensions of an Olympic pool are 50 by 25. The new pool is going to be similar, but it's only going to be 40 meters long. Okay? So when you're doing a word problem, you need to look for contextual clues like the fact that this is 50 inches, the length is 50 inches. So that's the number that you're going to use to relate it to this 40 meters long. So those are both length numbers. So when I write my proportion here and I write my scale factor, I'm going to do the town pool on the top the Olympic pool on the bottom. And the first number I'm going to write down is both of their lengths. So you see how that kind of has to match up. So their lengths have to go together. So the town length, it's almost like a multiplication chart. The town length pool is 40. The Olympic length pool is 50. So when it says ask to find the scale factor is just a reduced version of that fraction right there, 40 to 50. And it does say find the scale factor of the new pool to the Olympic pool. So the number that has to do with the new pool has to go first. So if you write down 5 to 4, it's wrong. Because the new pool is actually the smaller one. So the new pool is going to be the 4. The Olympic pool will be the 5, which is the reduced version of 40 over 50. Okay? And then if you wanted to find the perimeter, we could find the perimeter using P for the perimeter of that one, but we don't need to do that. Okay? If you go back to the last set of notes that you have, there is the homework assignments are still there, right? But if you'd like a new smaller set, I got a couple hanging on the wall there. We can get you some of a smaller one for the new one, or you can go back to the one that you have. So the assignment for tonight, we are on page. Let me pop it up here. I have smaller ones if you want smaller ones, but you have this from the last unit, the last set of notes packet that I put together. So we are on page 362, 1 to 22.